Just give me a minute.
Yeah.
Naveed, sorry for the interruption. Okay. So in the last class, we have done the image formation of the concave mirror, right? And so this is basically this is the summary of the thing that we have done in the last class. Achha, one more thing, Naveed. This is in inverse manner. We have taken the infinity case as the first case, right?
Yeah.
So just so don't get confused in it. Okay, this is just the opposite of that we have done.
Yeah.
Okay. Right, that's great. Now let's talk about the applications. So application is one of the important topic from which the questions come very frequently. That is basically our conceptual questions and basic questions, right? And where do we use the concave mirror in our day-to-day life? Okay. So first of all, Naveed, you must have seen that basically suppose that a man is shaving his beard, right? So he basically places the, you can say, mirror very close to the face,
Yeah.
right? So
Yeah.
okay, so in that case, the mirror used while basically shaving the beard is a concave mirror, because Naveed, in the last class we have we have discussed that when the basically when the focus, sorry, when the object is placed between the focus and the pole, okay, it will always produce a virtual and the enlarged image, right?
Yeah.
That means when you basically place the camera, sorry, it's not camera, mirror very close to
Yeah.
the face, the mirror will produce a virtual image and an enlarged image. That means the person can easily shave the beard. That is the first case of the human, you can say, like the real world application. Okay.
Yeah.
Second is basically you must have seen that women carries that woman carries a very small makeup kit,
Yeah.
right? So in that say, like they just open it, basically do some stuff like makeup, whatever
Yeah.
they do, right?
Yeah.
In that kit as well, make the concave mirror is basically installed so that the face looks very enlarged, so that they can easily lighten up the skin.
Yeah.
Clear, Naveed?
Yeah.
So this is one of the first important application that we see in our day-to-day life. Concave mirror are used as shaving mirror to see a large face and makeup mirrors for women. Clear, Naveed?
Yeah.
Good. Now, Naveed, suppose that you have gone to the dentist. So dentist need a very, you can say large view of your
Closer.
teeth,
Yeah.
because without that thing, he won't be able to proceed. He won't be able to treat you, right?
Yeah.
Because the, you can say that decay is very small, right? And the nerves and all the things are very, very minute. Okay. So to get a
Yeah.
large image of it, the dentist use a concave mirror as well to see the large image of your teeth. Please do let me know, Naveed, is that clear to you or not?
Yes. Yes. Yes.
Any doubt so far to you, Naveed?
No. No.
Are you sure?
Yeah.
That's great. Next is Naveed. Just give me a second. Let me give you a picture of it so that you can understand in a very better manner. Okay.
Yeah.
Where is the picture? So let me explain it on the board itself. Right.
Mm.
So suppose that, Naveed, let me draw it. This is a mirror. Okay. So you must have seen that the vehicle's headlight are basically are concave in nature. Have you observed that? They are concave
Yeah.
in nature like this, right? And a
Yeah.
bulb is basically installed at this place, like this. And okay. So when the bulb is placed at this place, the light produced by the you can say the vehicle headlights are very strong and parallel. Have you seen that or not?
Yes. Yes.
Any doubt? Is that
No.
clear? So that
Yes. Yes.
means, could you please tell me when the light rays would be parallel after reflection?
Uh.
In which case?
Yeah. What do you?
When the light
Um,
after reflection, in which of the following case the light rays would be parallel, Naveed?
in
Go
which
through a
of the
little bit.
in which of the following case?
Yeah. We have done 6 cases. After
Yeah.
reflection, in which of the following case the light rays are parallel to each other?
I'm not sure.
Fifth one, when the object is placed at focus, the light rays
Yeah.
are at infinite. The light rays basically are parallel to each other.
Yes.
Yes or no, Naveed?
Yes. Yes. Yes.
Good. So that means when the light when we use vehicle headlights, we place the source. This is a source.
Yeah.
We place a source at focus. This is a focus. That's why when the light reflects like this, goes like this, the light rays comes out as parallel lines after reflection. Because there is another reflector like this, it basically makes the lights parallel like this. Okay. Is that clear to you, Naveed? Please do let me know.
Yes. Yes.
Any
Yes.
doubt?
No.
Are you sure?
Yeah.
Good. Okay. So that's why. And same thing goes for the lens. Oh, sorry, the you can say the torches as well. Torch. That we
Yeah.
did torch. Okay. So where is the torch case? Here's it. So concave mirrors are used as reflectors in torch, vehicle headlights, etc. to get a powerful beam of light. Okay.
Yeah.
Next is Naveed. You must have seen very like factories in which we basically use hot furnaces like, but in Hindi it's called bhatti,
Yeah.
right? So nowadays, what happens basically, we want a renewable source of energy, and you can say we need you can say the sustainable energy instead of basically burning the fossil fuels, right? So
Yeah.
instead of that, we basically have this kind of mirror. Very large mirror is produced, and sun rays basically strikes the surface, okay, to heaten up the furnace. This is a furnace, okay, like this.
Mm.
Whatever the process is, I'm not sure about it, but that's the real world application that is basically done. Please do let me know, Naveed, is that clear to you or not?
Yeah. Yeah.
Clear? So
Yeah.
that's the use of the concave mirror, because I've told you that concave mirror, you can say, the merges all the light rays at a point. It focuses the light rays at a point.
Mm.
That means
Mm.
when the light rays are coming from the sun, it gets focused toward a single point. That means heat will be generated, right?
Yeah.
You can do the experiment using a mirror. Suppose that you have a mirror, very small mirror. Try to focus it on any like piece of paper. Once after 1 or 2 minutes, you will see that the paper will start burning.
Oh.
Okay, is that
Yeah.
clear?
Yes. Yes.
Chalo, that's good. I hope it's clear to any doubt.
Yeah.
Chalo, that's good. Okay. So please note it down fast, Naveed, the
Yeah.
applications of the mirror, and let me know once done. Completed, Naweed, so that we can discuss the convex mirror.
Yeah.
Check it. Let's go. Okay, that's great. Now let's discuss the convex mirror. What is basically convex mirror? As I've told you initially that if concave mirror is a converging mirror, that means convex mirror will act as a diverging mirror. What does it mean diverging? You must have seen that. Suppose that you have taken a spoon. So the outside part of the spoon, the outer part of the spoon will act as a convex mirror. Okay? And
Yeah.
convex mirror basically spread out the light rays in different manner, in different directions, right?
Yeah.
Okay, it does not converge, it's basically diverge. It spread out the light rays into the different forms. Clear?
Yeah.
Right. And one more thing, Naveed, as you can see from the figure itself, if the light rays are going like this parallel, it is basically reflecting back to the medium. Okay,
Yeah.
just a second, Naveed.
Yeah.
He is so lucky.
So it, as you can see, the light rays are being spread out. That means the reflection is not happening actually because the light rays are going out of basically out of each other like this. Yes or no, Naveed?
Yes.
Okay. So that means we have to extend them in the backward direction just to check whether they are basically originating from a point or not. Yes or no?
Yeah.
Okay. So that's why, as you can see, it's going backwards. So yeah, they are pointing at a point called focus. Okay. That's why I've told you that the light rays, whenever parallel to each other, basically, you can say converges at the focus, and they are not actually meeting. They are just illusionally meeting. Okay.
Yeah.
This is an illusion. Clear?
Yeah.
Any doubt?
No.
Sure, that's good. Please note it down and draw the diagram.
Yeah.
So write down the properties, Naveed, okay? Because we have discussed. Okay.
Yeah. Yeah, finished.
Let's understand the first case of the ray diagram. Okay. So let me erase it. So as you know that first, so the first case is at infinity. That means that the light ray will strike the surface
Yeah.
always when when the line is parallel. So it will strike the surface and it will reflect back into the same medium, but it will spread out it. Okay.
Yeah.
And after that, it's spreading out like this. So as you can see this thing, Naveed, both of the light rays are not spreading. Basically, it gets merging at each. Basically, they are not
Yeah.
going to intersect at each other, right? So
Yeah.
what we have to do is basically we have to see that whether they are merging in the backward direction or not. So I'm just extending them in the backward direction, okay, just to check. So as you can see over here, Naveed, okay.
Yeah.
So the light rays are basically at behind the mirror. Okay. Is that clear to you, Naveed Vijan?
Yes. Yes.
Any doubts so far?
And okay. No.
Sure.
Yeah.
Sure, that's good. Okay. And okay, so this is the case as you can see. So in mirror as well as lenses, all the cases when the object is at infinity, the image is formed at F. And over
F.
here, as I've told you that the convex mirror will always produce the virtual images. So here the nature of the image would be virtual and erect and highly diminished.
I
Okay?
did it. Yeah.
Because the light rays are being basically
Up.
intersected
Yeah.
at focus. Okay?
Focus. Yeah.
Yeah, that's great. Please note it down and let me know fast.
Yeah. Hello. 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 Mic check. Mic check.
Yes, Naveed.
Yeah. You can hear me, right?
Yeah, I can hear you.
Yeah.
What happened?
No, I was just checking the mic.
Achha, check. Please draw the first diagram.
Yes, finished.
Okay. Okay, next case is Naveed when the object, oh now in this case, the another case, the last case is basically when the object is between the infinity and the pole. Okay, so wherever you place the object between the infinity and the pole, you can see, okay. So I'm basically suppose that I am placing over here. Okay, so at this case, the first ray will always be parallel to principal axis.
Yes.
It will reflect back into the surface. Okay, and second ray will strike the pole and it will reflect back. Yes or no, Naveed?
Yes.
With the same angle. So as you can see this thing, Naveed, the light rays are not going to meet each other, the reflected light rays. Okay?
Yeah.
Clear?
Yeah.
Any doubt?
No.
Okay. Next is, so now we have to extend them in the backward direction to check whether they are meeting it or not. Yes, they are meeting over here. Okay. So just let me correct it a little bit. So this is, so if I extend them. So over here, you can see this thing, Naveed, that this is the focus. So, okay, so this is the reflection intersection, reflected rays intersection. So the here the image formed would be this blue color.
Yeah.
Clear, Naveed?
Yeah.
Okay, as you can see, the image is smaller than the object, and it is always formed between pole and the focus on the other hand side, between focus and pole. Clear, Naveed? Please do let me
Yeah.
know. Sure,
Yeah.
that's great. And the image would be virtual and erect and diminished. In this case, it would be diminished because it is having some height. Okay?
Yeah.
So I'm just redrawing it again. That was the actual image. Okay. Yes,
Yeah.
please note it down.
Yeah. Yes, finished.
Now let's talk about the applications of convex mirror. So convex mirror application is very simple and straightforward, and we use a lot of time in the real world. Like, have you ride any bike or drive any bike yet?
I don't
No.
know. No.
अच्छा ठीक है कोई बात नहीं, but when you will basically grow a little bit bigger and when you will basically learn the how to ride the bicycle or a bike basically or a car basically, there are mirrors basically placed at the side of the car or the bikes just to see the back, basically the back images, right? Which object is coming towards you and which one is not, like this, yes or no?
Yeah.
ठीक है. And okay, so that's why the convex mirror comes into the scenario. Okay, so we use convex mirror as a rear view mirror in our vehicles because Naveed, you can see this thing, the light spread out, okay,
Mm.
by the mirrors, okay, and it gives a wider field of view.
Yeah.
Clear, Naveed?
Yes.
Okay. So as you can see this thing, the light, as you can see, the field is more, yes or no?
Yeah.
Okay. But if you use the sorry, plane mirror, but it gives a smaller field of view.
Mm.
So why do we need? Because we need to see the more area behind us.
Yeah.
Okay, clear,
Yes.
Naveed?
Yeah.
Any doubt?
No.
Okay. And next is, if suppose that somebody don't have the basically the money to install the cameras. Okay. So as you can see, so they use the big convex mirror in this is entrance of the shop so that they can see the whole view of the shop. As you can see in the figure itself, everything is visible in the shop, just like a, you can say, camera.
Yeah.
So that's why convex mirror are used as the shop security mirrors. Clear, Naveed?
Mm. Yes.
Clear?
Yeah.
Please note it down.
Yes. Finished.
Just give me a second.
Yeah.
Just give me a moment. Okay, Naveed. So sorry for the interruption. Actually, there was. Are you there?
Yeah.
Okay, Naveed. So the next topic that we will be discussing is the mirror. So what is basically mirror formula? So Naveed, in the basically in the lens, in the reflection of light as well as the refraction of light, we assume that one basically light travels in a specific direction, like right. So for that thing, we have to discuss the positive and negative, you can say sign convention in the you can say the reflection as well as refraction. Right now, the sign convention that I will be using will be same for the refraction as well for the lenses. So if we are doing that thing right here, so there is no need to repeat this thing in the lenses part. Okay, so that's why we'll just complete this thing over here itself. Clear, Naveed?
Yeah.
Yep, that's great. So now let's understand this thing first of all. Okay. Naveed, as you can see, this is a mirror. So this is a mirror. So this is specific, not for a concave mirror. It could be any mirror, any lens. Okay. If you understand this thing, that means you can easily attempt it for the next one. Is that clear to you, Naveed?
Yeah.
Good. Next case is chicken. So over here, you can see this thing. So first of all, Naveed, we start from the pole. That is the origin. Just like the coordinate geometry we have seen, we have the origin. Just a second, let me draw the figure over here like this. Okay. Suppose that this is origin. Okay. And we assume that light travels in the right side of the direction. That means it travels in the positive x. Assume that. Okay. So that means, Naveed, if we are at here and we start from the origin, if we are going in this direction, we have a positive distance over here. Is
Yeah.
that clear, Naveed?
Yeah.
Okay. And we start from the origin. If we are going in the negative direction, that means it is a negative distance. Clear, Naveed?
Yeah.
Great. And we, first of all, Naveed, we have seen that we always place the mirror on the left-hand side of the, we always place the object on the left-hand side.
Yeah.
Okay?
Yeah.
That means when we start from origin and we are going in this direction, could you please tell me the object distance, Naveed, in this case?
Object distance.
Yes, object distance, will it be positive or negative?
Negative.
Negative, that's great. So Naveed, whenever we are talking about the real images, the images formed will be on the in front of the mirror itself. Okay?
Yeah.
So if you're going in this direction, that means your image distance as well as object distance would be negative. Okay?
Negative. Yeah.
And if the image is formed behind the mirror, as you can see, it is going over here. That means we're in the positive side. So
Positive.
that means it would be positive. Please do let me
Yeah.
know, Naveed, is that clear to you or no?
Yes. Yes.
Any doubt so far to you?
No. No.
Good. As the next thing, Naveed, the next thing that we have is basically, I've told you that concave mirror converges the light rays at this point, suppose. This
Yeah.
is F. So if
F.
you're
Yeah.
starting from over here, so what will be the nature of the, you can say the focal length?
Nature
Negative
of
or
the.
positive?
Yeah. Negative. I think.
Good. Yes, Naveed?
Negative. Negative.
Negative, na? That
Yeah.
means, as I've told you that the concave mirror has a negative focal length. Yes or no?
Yeah.
Right. And Naveed, we have seen that the convex mirror, the image is produced behind the mirror.
Yeah.
Okay. So that
Yeah.
means focal length would be positive for it. Yes or no?
Yeah.
That's why, as I've told you that in the previous class, that negative focal length is for concave mirror and positive focal length is for convex mirror. Clear?
Yeah. Yeah.
Any doubt?
No.
Sure. Okay. Achha, one more thing, Naveed. If the object is placed above the principal axis, that means it is upright. So this will be taken as positive height. And if the object is downwards, downright, it would be negative. So
Negative.
this is
Yeah.
all about sign convention. You will learn more when you will implement in the numericals. Clear,
Yeah.
Naveed?
Yeah.
Any doubt so far, Tibuche?
No.
Sure?
Yeah.
Sure. So please note it down fast. This is one of the important. Don't worry. When we will implement it, you will understand more. Right now, from the theory part itself, I hope it's clear to you so far.
Yeah.
Okay. Achha, one more thing, Naveed. There is a trick you can remember. Whenever the nature is concave, Doesn't matter whether it's lens or mirror, it will always be negative focal length. Clear?
Yeah.
And if it is convex, so it will always be positive, whether it's lens or a mirror. Is that clear to you, Naveed?
Yes, yes.
Please let me know any doubt so far to you.
No.
Sure, that's great. So please note it down fast and let me know.
Yeah. Yes, finished. Sir, you're muted.
Acha, sorry. Yeah. So now we'll be. Acha, have you written down these things as well? These
Yeah,
check it. Check it. Now the next thing that we have is the mirror formula. Naveed. What is mirror formula basically? Mirror formula is the formula that establish or basically gives the relationship between the focal length and the image distance and the object distance. Clear?
yeah,
So the formula is 1 by f equals to 1 by v plus 1 by u. And
yeah,
f is focal length, v is image distance, u is object distance. Okay?
yeah,
Any doubt?
yeah. No.
Good. So now next thing is basically the linear magnification. What is linear magnification, Naveed? Suppose that object is this, image is this. How do you
Yeah,
know that whether the image is small or the, you can say the big or the same size? There's a specific number that tells whether the image is same size or you can say smaller or you can say bigger. Clear, Naveed?
yeah,
Please do let me know, is that clear or not? So basically,
yes,
linear magnification is a way to basically is a way to get the idea whether the image formed is, you can say the image formed by the mirror is small, or you can say the same size or the enlarged. Clear, Naveed?
yeah,
Any doubt so far to you?
no,
Sure?
yeah.
Sure. Just a second. Check it. So how do we write linear magnification? Linear magnification is the ratio of the image to the object distance, image distance to the object distance with proper
Yeah,
sign convention. Is okay. Another definition that you can use is the ratio of height of the image to the height of the object. Okay?
yeah,
That will be called as the linear magnification. And m is denoted by the magnification equals to minus v upon u equals to h dash by h. Is that
yeah,
clear, Nabil?
yes, yes,
Could I end out?
no,
Sure.
yeah.
Sure. Please note it down and let me know once.
Yeah. Should I note down the linear magnification?
Linear magnification, sorry, mirror formula as well.
Yeah, Yes, finished.
But check it away. Okay. So next thing is basically Naveed now. How do we get to know that whether the image from the number linear magnification, whether the image would be enlarged small size or the small size? If Naveed, the magnification, this is basically the bars are called magnitude. Magnitude means we are not assuming the sign. We're just
Yeah.
saying the number. So if the number is greater than 1 in magnitude, in size, the image would be enlarged.
Yeah.
And if the number is equals to 1, then the image is of same size of the object.
Yeah.
Okay? And if
Yeah.
the image is less than 1, then the image is diminished.
Yeah.
Okay? So
Yeah.
if the number is greater than 1, that means if the magnification, that means V by U is coming out to be greater than 1, that means it is enlarged.
Enlarged.
Equals to 1, that it means it is equals to 1. So
Yeah.
it's same in size. And if it is less than 1, then it is diminished. Is that clear, Naveed?
Yes. Yes.
That's great. Next thing is the negative sign of the linear magnification refers to real and inverted nature of the image. What does
Yeah.
it mean? That means that we suppose that if the magnification is greater than 1, but there is a negative sign associated with it. Okay? That means it is a real and inverted image. So do not assume that negative sign is basically showing the magnitude. Negative sign is
Yeah.
showing the real and inverted nature. Clear?
Yeah.
Any doubt?
No.
Sure, let's go. Okay?
Yeah.
So with this, we have completed the linear magnification, Naveed. The next class, we will talk about the you can say the formulas of the mirror formula and the numericals associated with the mirror formula. Please do let me know, Naveed, is that clear to you or not?
Yes. Yes. It's
Any
clear.
doubt so far?
No. No.
Sure, let's go. Just a second, Naveed. So after this class, we'll be having the assignment.
Yeah.